Good morning, SL. This is Unit 1, Day 1 Notes, and we're going to talk about functions this chapter. So I'm just going to go over the basics of functions, some of the stuff you'll already know. First is a relation is going to be any set of points on the Cartesian plane, and we're going to talk about the x and y and how they relate to one another. These are some examples of a relation. I encourage you to go through them. A function is a special type of relation that we're going to talk about. Here are some examples of functions and not functions. We'll study the two sets and then make a conjecture. What do you think a function is defined as? What do you think makes this or these not a function? So let's look at these x values. We have 3, 5, and -7. And then our y values are 5, 5, and 5. Okay, so it seems that we can have a function that has the same y values. That's all right, as long as we do not have any of the same x values, right? We also know that this is a function, a to b. 1 to a is okay. 2 and 3 going to the same output is okay. And then 4 has its own output. Let's look at this. Looks like a sinusoidal, a sine wave. You'll look at this later when we go over trig again. And it looks like it says it's a function. And then we just have y equals 2x plus 4. You know that this is just a straight line. It just looks like a straight line going up, and that says it's a function, right? Let's look at what is not a function. It looks like we have the same x values right here. So when we have the same x values that have different y values, so we have one input that has two outputs, that's not a function. And that's kind of how this is what it will look like. If we have 2 is at 1 right here, maybe, and then 2 is at at 1, and then 2 is also at -1, this would not be a function. So we cannot have one input having two different outputs. So we have right here, one goes to A and one goes to B. No, that's not okay. And also, this x equals a number, x equals 10 is a vertical line. Vertical lines will not be a function, okay? I know you guys have seen this before. This is just kind of like a review. It says a function sometimes is called a mapping, but a function is a relation which no two ordered pairs have the same x-coordinate. So we can have the same y-coordinate, right? But as we saw right here, 2 goes to B and 3 goes to B, but we cannot have the same x-coordinate. That is, every element of the domain is mapped to exactly one output. It cannot be two. So I'm going to write that exactly one output. Okay? No more. All right, let's talk about x. What is this? X is our input because they put output. So I thought input. If this is our independent variable, f of x or y is our dependent variable. It really depends on what we plug into or we substitute into our equation, right? A couple of other terms you might not be familiar with is this is going to be an argument, or x can be an argument, or it can be a pre-image. I would write argument down also. F of x will be our image of x. We learned this in geometry, pre-image and image. Alrighty, go ahead and flip your paper over. It says, which of the following sets of ordered pairs are functions? So let's look at this one. We have all different x values, and we have all different y values. So this is definitely a function, right? So you can write down, yes, it's a function. Let's look at one that may not be a function. Well, let's look at this one. I'm not sure if it is. This one has the x value written twice, right? Actually, every time. But there cannot be two different y values. Are there two different y values? Is -1 different from 0? It is. This means that this is not a function. Let's try this one. Do you guys see that I have the same x value, but my y values are different? That means this is not a function. I want you guys to try D. I'm going to check it when next class and make sure that you did D. So I know that you guys have heard of this before. This is how we're going to test to see if it's a function. One of them, the algebraic test. If a relation is given as an equation, then the substitution of any x value results in one and only one y value, right? So we're going to say exactly 1, or we can say 1 and only 1. It's up to you. I used exactly before, so it's up to you. Something that you will remember. Only one value of y. Then we have a function. Okay, so let's do an example. Let's see if this is a function. Let's solve for x, or let's just plug in a problem or a number. So let's say if x equals 9, then our y equals 9 squared, right? What is 9 squared? 81. Since it's not two numbers, then we know that this is a function. So I'm going to say, therefore, this is a function. Uh-oh, what about this one, though? Let's look at this. Let's say that we plug in 9 again. So we're going to plug it in for x, substitute it in for x. I have to stop saying plug it in. Substitute it in for x. So 9 equals y squared. Let's see what happens. We're going to have to actually take the square root, right, of each side. But y can be 3, right? And y could be -3. If we substitute in -3 squared, that will also give us 9. So since there are two output values, we're going to actually have to say this is not a function. Capitalize it. Not okay. We have a geometric test for this, which I know you guys have heard of this. It is called the vertical line test. If we draw all possible vertical lines on the graph of the relation, then the relation is a function if each line cuts the graph only once. It is not a function if one line cuts the graph more than once. Oops. Oh no. I don't know what happened. Alrighty. It is a function if it cuts the line only once. However, it is not a function if one line cuts the graph more than once. Okay? So let's draw a line in this example 1 and then example 2. Let's draw a line and see if it passes the vertical line test. So I'm just going to draw a line maybe right here, And do you guys see that it does in fact only touch the graph once right here at the vertex, right? But it says that we can do it as many times as we want. So all possible vertical lines. Let's do it again. Let's try it right here at x equals 2. What happens? How many times does my vertical line touch my graph? So this function, or this equation, x equals y squared, it looks like it would touch it at 2 spots. So this in fact is not a function. Let's look over here. So I'm going to try number 2, and I'm going to draw a line straight down, maybe this line right here. It looks like it would touch it only once, and that would be right here. Pretend like it's a straight line. I can actually use a line. Okay, let's try this one. I'm going to draw a line straight down, maybe like right here. Do you guys see also that it only touches the graph once? Any straight line, any vertical line that you draw straight down, it'll only touch this graph once. This is a either sine or cosine wave, and this is a function. So on this one, we could put maybe right here, not a function. Right? But this one we can say, yes, it is a function. All right, let's keep going. Let's do an example. Okay, use the vertical line test to determine which of the following relations are functions. So I'm going to help you do a couple. Let's try this one, even though it looks pretty easy. Let's try this line right here. Do you guys see that any time I draw a vertical line on a straight line, it's going to be a function unless the line itself is vertical. Unless we had a vertical line. We kind of went over that earlier. So it looks like it does touch once right here. This is a function. Anywhere I put this black vertical line, it will touch my graph only once. So this is a function. It says circle all the relations that are functions. So I'm going to circle it. I'll just circle A. All right, let's try B. I'm going to draw a straight line down. Does it matter where I draw my straight line down? Does it really matter? I think each time it's only going to touch my graph once. This one only touched once, and this one only touched once. So this one is a function. I want you to try these. I'm going to look at H real quick. Let's look at H. If I draw a straight line down right here, that's only touching this one, right? It's only touching it right there because this is open. However, if I draw a straight line down right here, do you guys see that we're touching my graph 1, 2 times? That's not okay. So this one is not a function, okay? Let's look at this. You know what, when I first saw this, I wasn't sure. Let's look at this right here. But if I draw a straight line down right here, that doesn't really matter, right? But what about right here? This is actually an asymptote. So they're not actually touching the asymptote. They're getting infinitely close to it, but they're not actually going to ever touch it. So this right here is actually not going to touch the graph at all. So it will only touch the graph once. If I move it over, it'll only touch it once, not more than once. So this is a function that passes the vertical line test. All right, guys, try the rest out. And if you do have questions, you can ask me. All right, this is function notation. Your homework is going to ask you on this, so let's go over it. Suppose f is the function that will convert x into 2x plus 3. The function can be written as this. Usually we have squiggly brackets, right? And this is how you read this. I'm going to write it out for you. The function f And then the little colon right here in math means such that. Okay, that's what this colon means. Let me just make my arrow red. And then x, you can say, well, I'm going to write x goes to, and then 2x plus 3. I have also seen x is converted to 2x plus 3. Either one. I'm going to say goes to. Oh, you might have to use purple. Okay. Also, sometimes instead of f of x, you will see y. We already reviewed that on our math space. Let's do an example. It says if f such that x goes to 12 divided by x minus 1 squared. Find the value of f at -2 times f at -3. Let's try this. So this is going to be the same as y equals, right, 12 divided by x minus 1 squared. That's my function, 12 divided by x minus 1 squared. And they're just telling me to plug in -2 into the x. So we're going to plug in -2 to the whole function. So I have 12 divided by, and then parentheses, -2 minus 1, and your parentheses squared. Now, it's telling me to multiply it by the whole function when I'm plugging in 3 now instead of 2. I'm plugging in 3 to this whole function, which is 12 divided by 3 minus 1 squared. Okay? So -2 minus 1 is -3 squared, which is positive 9. So this one is 12 over 9. Let me just make it blue. Sorry. I like to color coordinate it. 12 divided by 9 times. The green one is 3 minus 1, which is 2 squared, which is 4. So it'll be 12 over 4. Okay? And then we're just going to multiply straight across. When we have fractions, the denominator, or multiplying fractions, the denominator does not have to be the same, and we just multiply straight across. So 12 times 12 is 144. And then 9 times 4 is 36. And I believe that does go into 144 4 times. Try it out, guys, on your calculator and make sure, because these are the type of mistakes I make, are the algebra ones, okay? Is this the same, or what is f of 2 times 3? Remember, parentheses are first. 2 times 3 is 6. So they're asking us, what is f at 6? This is really what they're asking us. Well, we've got to plug it into the whole function. Our function is 12 divided by x, which is 6, minus 1, quantity squared. 6 minus 1 is 5, so I have 12 divided by 5 squared, which is, I can put 25, or just put 5 squared. And then my next step, or my last step, will be 12 divided by 25. And then check to see if they have any common terms. I do not believe so, but they might. And then always factor them out if you can, okay? Simplify your fraction if you can. All right, let's look at example 2. All right, if our function, our function f such that x goes to 5 minus x squared. Find the simplest form of 2 times f at -x. So let's plug this in. We have a 2, and then we're multiplying 2 times our function when we substitute in -x for our x. So 2 parentheses, use those parentheses. This is my function. 5 minus x squared. But instead of x, I have to substitute in -x. It's only going to change some of it, not all of it. So I still have a 2, and then 5 minus a negative x is plus x. And then negative x squared is positive x, but I still have a minus out here, so I have to bring this minus down, and then x squared. That's it. And you can distribute your 2. I would distribute it. 2 times 5 is 10 plus 2x minus 2x squared. Okay? This is going to be your function. I want you guys to try this one out. So you're just going to substitute in x plus 2 in for your x, and then I want you to see if that is the same as your function, and then you add 2 to your function. Are these two things the same? After we're done going over this, after you guys solve this question, then I will answer it for you on the board. Okay? I'll go over it with you guys. Make sure you ask me. This is the third example. It says, if h of x equals 3x squared plus 2x plus 1, then find x if h of x equals 17. So what's really pretty cool is you're just going to use your substitution property. They're telling you that h of x equals 17, so you're going to substitute it in. 17 now equals the 3x squared plus 2x plus 1. And we're going to always, when we have a quadratic, set it equal to 0. So in order to do that, I'm going to have to subtract 17, right, to move it to the other side. And now my function is 3x squared plus 2x minus 16 equals 0. And then we're going to have to factor it. That's how we do this. And we do not have any common terms. I can't pull 3 out of 2. And I can't pull, there's no number I can pull out of all 3 of these terms. So what I'm going to have to do is just factor. This is how I factor. If you guys learn like the box method or the X method, maybe you can teach us, because that's going to be a little bit different. So I'm looking for the factors of 16. And I know that my first terms have to multiply to be 3x squared. So I know that this is 3x and x. It's my only option. Now the factors of 16, I've got options. I have 4 and 4. If I multiply 4 times 3 and then I subtract 4, I'm not going to get 2. But I do also have 8 and 2. Now where I put this 8 and the 2 makes a difference. This will change. So I'm going to make sure I'm writing in pencil. So do I put the 2 here and the 8 here? So 3 times 2 is 6. Minus 8 will be the difference of 2. So that's really what I want. Now I've got to look at my signs. When I multiply 8 times 2, I need a negative number. So one of them is negative. But when I add them, the bigger one needs to be positive, since when I'm adding them, it's going to be positive. So 3 times 2 is 6. That's smaller than 8. So I need my 8 to be positive and my 2 to be negative. If I did that too quickly, then try it on your own. Tell me what x equals. X equals 2 things. Okay? And then you're going to substitute in negative 3x plus 1 into each of these x's. And then you're just going to simplify it. You can't really set it equal to anything, so you're not going to be able to solve like we did on A. Okay? Try them out. Now we went over set notation. Now we need to look at interval notation. So when we have a solid circle here at the 3, this means that it is inclusive. It includes 3. So I'm going to write this, inclusive. Right here, we see where the 2 has an open circle. This is exclusive. You need to know that stuff. Our interval notation says we're going to start at 3, and then we're going to go on this way, well, forever, right? We're going on forever. That little arrow means I don't stop. So my next number is going to be infinity. Now, at 3, I'm going to use a bracket because I can include 3, but I can never use a bracket for infinity. It's always got to be a parenthesis. So now I'm going to start at 2, but I'm going to the left infinitely. So I'm starting at, really, I always start from left to right. So I'm starting at negative infinity, and then I'm going all the way up here until 2. I cannot include 2, and of course, since infinity is not a number, I cannot include infinity. I'm going to show you what this looks like in interval notation also. So we're always going to have a squiggly bracket x such that x is, well, it looks like it's always going to be greater than 3, right? Like 4, 5, 6, and it goes on forever. So x is greater than 3. But it can equal 3 also, so I'm going to put a little symbol right here. That means it can equal. So x is greater than or equal to 3. I'm going to do the same thing over here. So I have a squiggly bracket, x such that, what are we going to do here? So x is not greater than 2 because it's not over here. In this case, it's going to be less than 2, right? And since we're not including 2, there's the circle is not shaded in, I cannot add that little equality symbol. I encourage you to read this, the domain and range of a function. For each of the following graphs, find the domain and range, okay? I'm going to help you with, let's do C. So I want you guys to do A and B. I think C is the hardest. All right, C. So I'm going to do set notation first just because it asked me to. So we're always going to have a bracket, x such that, let's look at my x values. It looks like they go infinitely to the left, right? And then they kind of like stop right here at x equals negative 2. And then they keep on going infinitely to the right. So it's all the numbers except when x equals 2. Okay, I know how to do that. So x such that x does not equal 2. Everything except for when x equals 2. Let's look at interval notation. This is going to be a little bit different. Whenever there's a break like this, we're going to use a symbol, a union, a U for union. So we're going to say, well, we're going to start over here. We always go from left to right. So I start over here. I have an arrow. So this means negative infinity, right? This one had an arrow. So it means it goes on infinitely. So negative infinity to, well, I have to stop right here at 2. There's like a hole here at 2. Okay. Parentheses, because we cannot include 2, and we cannot include infinities. Now I'm going to start again at 2 because it goes infinitely close to 2, but it's never going to touch. And then it's going to go on infinitely to the right. Okay, so to the left is negative infinity, and to the right is infinity. We don't really put a positive in front of it. It's just infinity. Okay, parentheses. Just use your parentheses. Now your domain, is your x values. But what is range? What is the range in this case? My range is going to be my y values. Okay, it looks like we're always going to start with the bottom and all the way down, 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 down means negative infinity. And up, all the way up, up, up. If we have an arrow going up, this means infinity. We don't put positives next to our infinities. So we always start with the bottom when we're looking at the range. And it looks like I do have an arrow that goes down. Down, down, down. That means that we're going to start at negative infinity. We're going to go up to this line right here. It looks like there's a horizontal asymptote as well at y equals negative 1. And then we're going to start up again at y equals negative 1, almost touching it, and then go all the way up, up, up to infinity. So again, we're going to have a squiggly bracket, y such that y is all real numbers except, or everything except when y equals negative 1. That's not okay. Now let's look at interval notation just like we did for the x values. We're starting down here at negative infinity, and then we're going to stop when y equals -1. So I usually use a ruler and I go up, 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 up till y equals -1. Okay? So negative infinity to -1, parentheses, because we cannot touch those when we have a asymptote. We're never going to touch that number. And then we have a u. I put an actual u. It doesn't have that extra little line. Just like that. And then we're going to start off again at -1, and we're going to go on infinitely. Okay? Our asymptotes, it's asking us for them. Our asymptotes, our horizontal asymptote means left to right, and that's when y equals -1. And then our vertical asymptote means up and down, and this is when x equals, what was it, 2, I think? Let me check. Yes, at x equals 2. Okay. I can go over these more. I want you guys to try out A and B by yourselves first, and then I'll go over it if you guys have any questions. All right, sketching functions and state your domain and range. So this is going to be for you guys to try. I'm going to ask you, I think this is your homework, right? And we'll go over it next class.